In today's video, we are going to go over some example problems for Ohm's Law. In a previous videos, I made an explanation for Ohm's Law and also for electric current and resistance and resistivity. You can link to all of those videos in the upper right-hand corner of this video. Before we get started, please don't forget, subscribe to my channel. Get all my excellent physics, chemistry, and math videos. Please help me reach my goal of 100,000 subscribers. Please subscribe and don't forget, leave me a comment also in the comment section below and let me know what you think of the videos and the channel. Thank you very much. And here we go. We're going to go over some example problems. I think I have 5 or 6 problems here. It says here, what is the voltage? What voltage will produce a 0.35 ampere current when that is hooked up to a resistor that has a resistance of 750 ohms. Now remember, this is Ohm's Law, which is simply V equals I times R, or as my mother used to sing to me at night before I would go to bed, twinkle, twinkle, little star, don't forget V equals I times R. We're given the current, we're given the resistance, and therefore we know that the voltage that would produce that current across or through a 750 ohm resistor would be 263 volts. Okay, there you go. Number 2. Now this time we have a hairdryer, and the hairdryer is drawing 6.5 amps of current, and it's plugged into a standard 120 volt outlet. And we want to know what is the resistance of that hairdryer, the heating element or the hairdryer, and we want to know how much charges would pass through that hairdryer with that current in 5 minutes. We're going to do 2 things here. We're going to start off with V equals I times R, Ohm's Law. We want to know what is the resistance of the hairdryer, so that means that R, the resistance, is equal to the voltage divided by the current. We're going to put the voltage in there, 120 volts, 6.5 amperes, and we get that the resistance of the hairdryer is 18.5 ohms. Now the second thing is just how much current, or excuse me, how much charge passes through in 5 minutes. Now we're going to use our current equation, which we talked about in our electric current video, which you could link to in the upper right hand corner of this video. And it says that the current is equal to the change in the charge divided by the time. So that's kind of the definition of current, is charge divided by time. Okay, we're not using V equals I times R this time. We're using the other equation we have, or one of the other equations we have for the current, and that tells us that the charge is going to be equal to the current times the time, because we want to know right here, it says B, how much charge passes through. So we have 6.5 amperes. Remember that the current has to be in seconds. The time has to be in seconds, and we have 5 minutes, and 6 times 5 is, because 60 seconds in a minute is 30, and that would give us 300 seconds. Because the current is in coulombs per second, the seconds will cancel, and we get that that would be 950 coulombs of charge would pass through that hairdryer in 5 minutes. Number 3 is simply the heating element of an electric heater has a resistance of 10.6 ohms. What will be the current when it's plugged into a 240 volt source? So in this case, we're going to start out with Ohm's Law, V equals I times R, and we want to know what the current be. Now in this case, we're given the voltage and the resistance, so we're going to use our Ohm's Law equation rearranged for current is the voltage divided by the resistance, and that gives us that 240 volts divided by the resistance of 10.6 ohms, and that tells us the current is 22.6 amperes. Okay, coulombs per second. Okay, the next one says here that what voltage, okay, so we have a voltage, and must the battery have to produce half an amp through a 4 ohm resistor. Okay, now we're going to do this one again. V equals I times R, current 0.5, resistance 4, 0.5 times 4 is simply going to be equal to 2 volts. All right. Now, this one we have, okay, we're going to do a little bit of research on the human body and the resistance and the current for the human body. We have to research the electrical properties of the human body. One electrode is placed on the patient's wrist. So you place an electrode on your wrist, tape it on there, and another one on your shoulder, and you have your arm as kind of like a wire. Okay, and we're going to put across those 2 electrodes 100 millivolts. And we're gonna measure that when we do that, we get 12.5 milliamps. And we want to know what is the resistance. So we're going to start off with V equals I times R. We have that R is equal to V divided by I, the voltage. Now we're going to convert, we don't really necessarily have to do this, but I did this because we're both in milliamps, but it should be just in volts. So I have 100, and milli is times 10 to the minus 3, because it's milli is 1,000. And so we have 100 times 10 to the minus 3 volts. And we have 12.5 times 10 to the minus 3 amperes, because it's milliamperes. We have volts and amperes, our base units there. And then we can see that these will actually cancel. And it's just going to be 100 divided by 12.5. And that would be 8 ohms of resistance along your arm there. When you place that voltage across the arm, you get that current because your arm has resistance of 8 ohms. Okay, now we have, I think this might be the last one. Now you're going to be in the, excuse me, you're in the shower. And of course you come out of the shower and you're going to grab the hairdryer to dry your hair. And you notice that you touch the wire because the wire is frayed and coming off, the insulation is coming off the wire. So you get through your body 120 volts. Okay, now your body, when it's wet, especially has a resistance of about 400 ohms. You want to know what the current will be through your body. So the current flows through out the wall, along the wire, out the wire, through your body, and into the floor, into the ground. And that means that the current is going to be the voltage divided by the resistance, and that's 120 volts divided by 400 ohms, and you get a current of 0.3 amperes. Okay? So there you go. I think that was all 6 of the problems that we were going to do. I hope you found that video helpful. That's some basic Ohm's Law problems. If you found that video helpful, please do all of the following 4 things. Subscribe to my channel. Get all my excellent physics, chemistry, and math videos. Let's see. Give me a thumbs up for this video. Leave me, please, a nice positive comment in the comment section below. And don't forget, sharing is caring. Share this video with all of your friends. Show them just how much you care. Subscribe. Get me to 100,000 subscribers. Thanks. We'll see you in the next video.